Okay, this is the third video on Section 3A, solving inequalities and graphing inequalities. And this is kind of where you need to pay close attention. So I stopped the video and I forgot what I said when I introduced the video, but this is the third one on solving inequalities. And this is important stuff here in example 3. This is where inequalities are not like equations. So this is another gotcha. So I want to walk through these examples, and I want to introduce you to the idea of why we have to have a special situation when we're multiplying or dividing by a negative coefficient at the bitter end when we're solving inequalities. So this is -4 is less than 2, and of course that's a true statement. And remember, what you do to one side of an equation, you have to do to the other. So the same applies with inequalities. So let's just take an example, and let's add, here are the 2 points, the target points, -4 and 2, and let's just add 2 to both sides. So -4 plus 2. And our question is going to be, is this really still less than 2 plus 2? And yeah, -2 is less than +4. And if we plot these, and let me put the 4 in green, and I'll plot the -2, the smaller number, down here in red. So it works. Yes, -2 is less than -4, so if we add a number to both sides, a positive number to both sides of the inequality, we still get a true statement. What about subtracting? So if we take -4 minus 2, is that still less than the 2 minus 2? And we get -6 less than 0. And again, that's a true statement. So the 0 is the larger number. He's right there. The -6 is right there, and this is the same order, the smaller number and the larger number. So that seems to work. Let's multiply by a positive number. So we started with -4, multiply that by 2. Is that still less than 2 times 2? And -8, indeed, less than +4. So it looks like all of these cases are working for us. There's +4. There's -8, see 5, 6, 7, 8, right here. So this all was working. So let's try multiplying, or dividing by 2. I guess that's the next one. So if we take -4 and we divide by 2, is that less than 2 divided by 2? So that's -2, and that side is 1, and again we've got a true statement. So this one's looking good, this one's looking good, good, and good. Let's plot our points. 1 is here, -2 is right here, and that's all well and good. So here comes the first exception, this guy right here, multiplying by -2. So let's set it up like we did the other ones, and we'll take the -4 that we started with and multiply it by -2, and we're asking ourselves, is this in fact still less than 2 times -2? And here's where it falls apart, because a negative times a negative makes this a positive, and our statement that 8 is less than -4 does not work. That's not a true statement. If you go plot them, if you needed a visual to see the points plotted, you're going to have your 8 right here, and you're going to have your -4 right here, but 8 is not less than -4. Oh, I should have plotted one of those in red. Sorry. So we got to take care of this situation, because right now we have a statement that's not true. So we did the same thing to both sides of the inequality, but it didn't work when we multiplied by a negative number. It was fine when we multiplied by a positive number, but it didn't work so well when we multiplied by a negative number. So we've got to remember this one. We're going to have to do something about him. What about dividing by a negative number? -4 divided by -2 less than 2 divided by -2. Again, we get a positive number. We get 2 is less than -1. And again, that one's false. So both of these situations have not worked out well for us. What about if we square both sides? So we have -4. If we square him, is that less than 2 squared? Once again, a negative times a negative. -4 times -4 is going to be +16, less than +4. And of course, that one's not true either. So we've got 3 situations. I'll erase that star. We've got 3 situations here where our rules of doing one thing, the same exact thing to both sides of the inequality, is not working well for us. So we've got to make a rule. We have to have a way out of these 3, of making E, F, and G true statements. And you probably can see it for yourself. What can you do to make it a true statement? You can flip the sign. And if we flip the sign, in these 3 cases, we end up with a true statement. So that's what we're going to end up doing. Let's go ahead and fill out this vocab. So it says to solve linear inequalities, you can use the same steps for solving linear equations with the following exceptions. And these are our E, F, and G examples. When multiplying or dividing by a negative coefficient, the direction of the inequality flips. So this will be the last step that you do to get your variable alone. And you just have to remember, when you're multiplying or dividing by a negative number, or you're squaring a negative number, you're going to have to flip the inequality symbol. So here's a couple examples. We can add 1 to both sides. We get 2x less than 10. I'm going to divide both sides by 2. I'm dividing by a +2, so I don't have to worry about the sign. X is less than 5, and I'll leave the graph to you. Well, I'll plot it real quick. So my target number is 5. I usually put a number on the right and a number on the left. I'm going to circle my target number. I'm not going to fill them in because there is no equal to line underneath the inequality, and I want all the numbers that are smaller. So I'm going this way on the number line. Be sure to put an arrow at the end of your line to show that this goes on forever and ever. Let's look at this one. Subtract 2 from both sides. We end up with -3x greater than 12. I'm dividing both sides by -3. -3 is my coefficient. It's negative. I have to flip the sign. And generally speaking, that's the first thing I do before I write down anything else. So now we have x less than -4, and you can graph it. All right, we're going to just do a couple on the next page, and then we'll work some in class. So this example, we're going to subtract 4 from both sides. And we end up with -x divided by 2 less than or equal to 1. In order to get rid of the -1/2, which is this denominator, we need to multiply both sides by a -2. That will turn this x positive, which we need him to be, and it will also take care of canceling out the 2 in the denominator. But again, I'm multiplying by a negative. Alert, alert, flip the sign, and now you can go back and fill in your answer. Positive x greater than or equal to -2. Let's do one more. We need to clear out the 3, the denominator, so we can multiply. If you think of this 3 as multiplying to both terms on either side of the inequality, the 3's cancel, and you get 8 minus u greater than 6. Subtract 8 from both sides. Minus u greater than 2. -2. There we go. And this is all well and good, but the u needs to be positive, so we need to multiply both sides by -1, which means we have to flip the sign. And now we have positive u less than +2. We'll work a couple of these more complicated or at least longer problems in class when we come in as a little bit better practice for us. So this is the end of this video. Thanks for watching.